Hi, I'm Jessie, the marketing coordinator for Xyonix. As someone working in the AI sphere without a deep technical background, the news this week had me wondering, what's all this fuss about DeepSeek? Have they really cracked a cost-effective way to train and run AI models? And is their aim of reaching artificial general intelligence something we should even pursue? Luckily, as a Xyonician, I have access to AI practitioners with decades of experience. I sat down with Carsten Tusk, our co-founder and chief data scientist here at Xyonix, to get answers to these pressing questions about DeepSeek, its impact on large language models, and some other broader AI issues. Let's dive in. Digging into the actual research paper of DeepSeek, I'm not an AI expert, so first question is, why do people think this is a big deal?
Well, I think it's because they published the numbers of what it took to train the model, and they are significantly lower of the money that was put into the models that, let's say, OpenAI trained on Microsoft or Google. And so the whole hype behind AI and NVIDIA's rise to fame is that, hey, we need billions of money for chips and data centers, and we need this big compute to do this. And here comes this tiny company and says, well, we did this for $6 million. And it's on par with the performance of your large-scale models. And so I think that's where the big deal came from.
That makes sense. When I was kind of delving into it as well, I saw that there seemed to be a distinguished part between OpenAI having open source models and DeepSeek having open weighted models. Is that a big deal? What's the difference there?
That's a really big deal because and OpenAI doesn't really have open source models that way. But if you have the weights open, then anybody can run that model. So basically, you can leverage the $6 million that DeepSeek put into the training of that model. You grab the weights, you run it for yourself. And they published all the details, down to the smallest detail, how it was trained. So you can continue training it, you can build upon it. So it's really they're contributing back to the research community and say, hey, we did this, it works really well. Here's how we did it. Here's exactly what we did. You can do it yourself. Whereas OpenAI is a little bit more, closed up. It doesn't really tell you exactly what they do. Even their technical reports are kind of fuzzy. They leave details out. You don't really exactly know what data went into an OpenAI model or how it was trained. Kind of like their, intellectual property.
Yeah, that makes sense. You said that people could just run this on their machine, but I assume that it probably takes a lot of processing power, wouldn't it?
Well, so if you want to run the full thing, it has about 671 billion parameters. A billion parameter takes about a gigabyte of memory. So you need about 671 gigabytes of memory to run it if you want to, the full model, right? But I recently read an interesting article where somebody just went out and built a little PC for about $6,000 and had a terabyte of memory, and he runs the whole model on it. Granted, you have to take that with a grain of salt because, yes, it runs on that hardware. No, it's not very fast. It generates 6 to 8 tokens per second. So if you think back to the 80s when we had these 300 baud modems, it's about the speed that it would respond to you. You can play with it personally, right? You can't use that to, let's say, run a business or have more than one user on it, even, right?
Okay. That makes sense then. One of the other things that stuck out to me, and we'll have to get a little granular with this because I don't know all of the definitions, but when I was reading their paper was that they trained the model using large-scale reinforcement learning without this preliminary step of supervised fine-tuning. And the way they seemed to phrase it was that most other companies use supervised fine-tuning in their model development, like it's a default step in training an LLM like this. Is that true?
So that was their first experiment with DeepSeek v30, right? They used pure reinforcement learning to train it just to prove a point and to see if this can be done. The advantage of that is, especially if you have things like math and things that are kind of verifiable, is you can generate all this ground truth data that you need for the training automatically, right? Because you can just spit out math equations, you know the answer already, and so you can use that for training. And reinforcement learning is basically you give it an example, you rate the results that come back, and you give them a score, a reward, right? And you reward the good results more than the bad results, and it learns a policy based on that, what is good and what is bad. So they tried this with pretty decent success, but the model wasn't quite on par with the real model. And so if you read the paper, what they did in their final version is they actually did use supervised pre-training. They have this cold start data that they bootstrap the model with. And also the whole model is not doesn't come from nowhere. They used their DeepSeek base model that was trained on regular 14 trillion tokens to bootstrap it. So it's kind of like the same process that everybody else uses. You have a base model that is just a generative model. It doesn't do question answering or anything. It's just a token generator. But that has been trained on lots and lots of content. And then they use that and tune it into these models. Let's say a question answering model or a chat model using reinforcement model by feeding it learning by feeding it specialized content. I think what they've shown us is really that the power of reinforcement learning, if you have the right applications and data to go beyond of what you can do with, let's say, like a big web crawl or something, because you can artificially generate data. There's one problem with that. It only works in cases where you can really make a judgment whether or not the response of the model is actually good, because you need that reward function. And you need to be able to say this is a good response and this is a bad response, right? Mm-hmm. Many of the tests that they have, let's say science tests and math tests, anything where you can verify whether or not the response is good is a great candidate for that.
Okay, that makes sense. Because I was going to ask kind of what do you mean specifically by on par, but the way you just explained it helped a lot. Okay. So then another thing that I was reading through, and it seems like DeepSeek and O1 specifically had in common, was this like chain of thought reasoning process. So whenever I'm using O1 and I'll see it actually like, oh, I'm thinking, and then it'll walk me through the steps that it is thinking, breaking up their steps, mimicking human reasoning in that way. Does the chain of thought process improve model performance? It sounds like yes. And how does it do that? Are there limitations to this process?
Yes. So one thing people found out is that LLMs are not very good at compound reasoning. When you have to follow many steps and one builds upon the other, if you present a problem like that to an LLM in its closed form, they have a hard time with it. One way around that is and that's something that we implicitly do when we like teach kids math, right? We take like this complicated thing and we break it down into little steps. So, in order to solve this equation, you solve this equation first and then this and then this, and then you combine it all together and it works. Basically breaking a big compound problem into smaller sub-problems has shown to be really helpful because the LLMs can solve the small sub-problems, right? And then they can combine the results of that. So the chain of thought helps them to solve these bigger questions by breaking them into little ones.
Mm-hmm. That makes sense. I mean, that's how we learn as people, so it makes sense that it would work better for LLMs as well. Also, in their research paper, DeepSeek claimed that like this was their first step towards their goal of exploring the potential of LLMs to develop capabilities without supervised data. Could you kind of explain what supervised data is? Because I wasn't familiar with the term, and then kind of what the advantage of building an LLM without supervised data might be.
Well, so it's a little bit of what we talked about earlier. Supervised data is if you have a human generate examples, let's say, right? For example, the human says, here's the question, here's the answer. Somebody supervised that and says, this is a training sample, please, you use that for training. So you could say like a web download is also supervised, right? Because you have ground truth, not that the web is true, but ground truth. And you feed it to these models and they learn from this supervised data. But you're limited to the domain and the amount of data you have. And depending on what that is, generating supervised data is expensive. Let's say you have human annotators, like we sometimes have projects where we have humans annotate our data. Mm-hmm. That is really labor intensive, right? So generating lots and lots and lots of supervised data is very expensive. So if you had any way to do that automatically, then you could train with maybe more data. It has been shown that the more training data you have, the better these models become, right? So you want to really cover your domain exhaustively. And so in this case, like I said, when you have a problem like math or anything that is validatable, where you can automatically generate the training samples and the correct responses, let's say using an algorithm or any other means, and you don't need a human to generate these supervised examples, then you theoretically can generate infinite amounts of training data. Mm-hmm. And so that is way more beneficial than trying to find real data.
Mm-hmm. Do you think there's also a chance that if the data is automated like that you could kind of, I'm not sure if this would be true, but almost diminish the amount of human bias that goes into the training data? Would that be possible? Or would it always be present?
You can make an effort, but after all, there will be a human that writes the algorithm that generates the data, right? So there's some bias there. Bias is a tricky thing.
Mm-hmm. It's one of the more fascinating things in my experience for talking about AI, because it does seem like inevitably these models are going to be biased. There's almost nothing that we can do to make them unbiased.
Well, it's because nature itself and the world is biased. And if they learn from the world, they're by definition biased, right? Yeah. Like bias is even in the data distributions that we look at, simply by the representation of, let's say you have a minority group Well, it's represented in a minority. There is a bias that this is a minority, and so its representation is less. And if you would actually artificially inflate that and make the minority equal to the rest, well, then you also falsified your data. So what is bias and how to get rid of it? But that's a whole
but it is really interesting.
different story.
Yeah. All right. Going a little bit back to DeepSeek, but generalizing, how do you see this impacting the broader AI ecosystem, specifically in terms of China globally, how the US is going to be reacting to this?
Honestly, not at all. I don't really share that hype that people have here. I mean, here's a research group in China that came up with a good, efficient way of training a model, exploring how far they can go with reinforcement learning. They're not starting from scratch, right? They're literally building on the success of all the models that OpenAI and everybody else have developed, right? This is on top of that. From my perspective, they have shown us that if you have these preconditions, if you have a space where reinforcement learning can be applied, you can have very, very good success with smaller models. And, it really reduces the cost in training models, especially if you can use an existing large model as like your bootstrap and your base, right? And so I think it was a good success. It doesn't deserve the hype that it's currently getting. And it certainly doesn't really have a big influence on, where the investment in the US goes or anything else. At the worst scenario, you could say, well, great, they just showed us the capabilities we can now reach with less GPU power. Now let's take that same principle and apply it with the full GPU power. Do we get a better model? Maybe. At the end of the day, you still need the full GPU power.
Mm-hmm.
And just to put some numbers into it, this is not that cheap, right? DeepSeek has a cluster of 2,400 800 NVIDIA GPUs. That cluster itself cost them $150 million. So yeah, the training cost is $6 million in electricity, but buying the thing that you can run it on is another $150 million. So
yeah, everyone seems to say that this is like so significantly more cost effective, but it sounds like AI is just always going to be kind of expensive. It doesn't sound like there's many corners you can cut when you're running models like this.
I think we're getting better. There's a lot of little optimizations. And if you read through the paper, they talk about a lot of them, right? They use like 8-bit quantization. This is where you go like from 32-bit floating point accuracy down to 8-bit. And they found it doesn't have a huge impact on the actual performance of the model, but it's much faster to compute with it. So there's a lot of little optimization techniques down to the algorithms that they're using.
Mm-hmm.
So I think we'll see like marginal improvements there, but nothing massive.
Okay, that makes sense. I did see the interview with I think it was the founders of DeepSeek or the main researchers on the project. Yeah. So I wasn't able to read through the whole thing, but I did my best to skim it. I did notice one thing that stuck out to me is that DeepSeek's founder, I think his name is Liang Wenfeng or something, says that their goal is AGI, artificial general intelligence. Do you think their focus on this foundational research aspect rather than the applications is the right strategy for achieving AGI?
Absolutely.
Mm-hmm.
Yeah, because we're not there yet, for sure. These models are good, they're impressive, but they're not what I would call AGI, far from it. Even speaking of the efficiency we just talked about, I mean, everything is based on transformer models right now. But some other papers have already shown limits of what transformers are actually capable of and where their limits in reasoning are. It is not entirely impossible that we will see a different network architecture that will arise in the future that might achieve something better than this and is better at reasoning. I think the foundational research is really, really necessary. And we shouldn't think too much about applications right now because honestly, I think they're very limited right now. This is good. This is really great for content generation, but it is not good to solve problems where we need any sort of guarantees on accuracy, for example. Right? If you're okay with this thing being 20% wrong, right? And nobody dies if that is the case, no planes crash, etc., etc. This is great technology. But if you have these requirements, there's currently nothing we can do to fix a model, right? So there's work to be done.
Yeah, absolutely. Kind of in the same vein, do you think if you had to put your eggs in one basket, do you think that scaling these transformer models alone will lead to AGI? Or do you think it's more likely that these fundamental network architecture breakthroughs are still needed?
Scaling these alone will definitely not lead there because I forgot which paper it was, but researchers have already shown that there are mathematically hard-proven limits what these transformer models with attention can actually solve. And there's a class of problems they can't solve. And while that is the case, you can scale it as far as you want, that theoretical limit that has been proven will not be overcome by that. We definitely need a different architecture if we want to really solve these issues.
Another thing I was kind of curious about, do you think we want AGI, or do you think the potential for misuse of things like that is too great?
Well, let me ask this question. Do you think AGI is even possible?
Me personally, with no amount of AI expertise, I don't think it is. It depends, I suppose, on your definition of AGI, and mine is a very rudimentary definition of some semblance of consciousness or sentience, but how do you measure that? How do you put a label on that? So I don't think so.
I think we're pretty far away. Yeah, it's almost a philosophical question, right? If you think that we are just like biomechanical, deterministic beings, and if you could, let's say, replicate your brain atom by atom by atom, there's an interesting question me and an ex-colleague of mine had. It's kind of like, if you could do that, if you have the Star Trek teleporters and you could replicate yourself 1-to-1, would that second being, would that be alive or not? And it boils down to the question, is there something more than the biochemical, physical aspect of human beings, their conscience or not? I don't have an answer to that, to be honest. That is a very philosophical question. So on the biomechanical side, yeah, if we can figure out why our brains work the way they are, we can construct artificial neural networks that are similar to that. Mm-hmm. And we want to call that AGI, maybe, but even that is a science fiction pipe dream right now, right? Right now we just have these multi-head attention transformer models that are really, really good at, let's face it, pattern recognition. It's still a pattern recognition thing. We show them all the possible patterns in the world, and they will assign a likelihood, given this pattern, that this pattern will appear. There's no real reasoning there. There's no real thinking there. It's just recombobulating what was fed into it.
I agree. I think, personally, I'm happy that AGI is a bit of a fan fiction pipe dream right now, and I'd like it to stay that way. What's one thing about current AI models, you'll probably have a few, that you think is really overhyped? And what's one thing that you think is underappreciated? I know.
Oh, God. What is overhyped? Oh, I don't know. Is there hype?
Yes, I would
I don't follow it.
I would certainly say there's hype. I'm in a lot
of... Why do we turn that around? You tell me hype, and I'm telling you why it's not a hype.
I definitely, personally, in my life, obviously, I'm a marketing person. I'm on, like, Reddit is my personal most used form of social media. I love Reddit. I follow a lot of AI-related subreddits like ChatGPT, now DeepSeek, things like that, in part because it's interesting, in part to kind of just stay up to date if I want to, like, cross-post to Xyonix something there. One thing I've seen increasingly in the past few months that is getting incredibly concerning to me is people talking about how they could not function without ChatGPT and how it has become such a staple in their life, from everything to making grocery lists to, like, essentially a therapist. So that is something that I've seen more and more and more of. That's just my personal anecdotal evidence.
I don't think that is hype. I think that is absolutely true. It is an incredibly useful tool that helps you with all kinds of content generation. I would compare it to, let's go back 20 years, search engines. There was a life before search engines. We went to the library. We had to go and look in books for things. Unthinkable these days. Now you have the knowledge of the world at your fingertips. You want to know anything about anything, you can put it into a search engine. And to me, these big models are just kind of like the extension from that. I think they're a better search engine. They can do more things. It's just a logical extension of that. And just as we couldn't imagine life without a search engine anymore, I think people will become used to these capabilities really quickly and can't live without them. I don't think that's hype. I think that's true. And it's very useful for things like that.
Mm-hmm. I do agree with that. I think perhaps the one difference that I think is going to make a bigger impact than we even realize right now is that I think it's easier to distinguish from a Google search if it's not the results you want. ChatGPT will confidently try to convince you that it is correct on a lot of things.
Oh, absolutely.
That's something that is going to maybe cause a few issues in the future.
So, and that kind of goes back to what we said earlier. Like, there's great applications for this, but they still need the human supervisor at the other end that makes that judgment call. That is true and that is not true. What worries me there is if people that are unable to make that judgment call believe what they're being told. There's a risk there, so there's a danger in that.
Mm-hmm. Absolutely. I don't know if you saw, a little off topic, but OpenAI is announcing the Stargate project where they're putting in like 500 billion, I think, over the next few years into establishing more like AI regulatory bodies. They're, I believe, working directly with the government to establish those. So it's going to be kind of a crazy 5 years. I'm not quite sure what to make of it or what to come out of it. The announcement was very vague, but
I honestly do not know how you can regulate this. We cannot really even 100% control what an AI or an LLM spits out and tells you. Sure, you can train other models to detect things like hate speech and things like that. But when it comes down to simple checking whether or not something is factually correct, there's no solution for that. They can't do it. I don't know what we're going to see there or what kind of real impact these regulatory bodies will have. My estimate, it's just kind of like one of those due diligence pro forma things where do you have measures in place to protect against this? Yes, check. But at the end of the day, the fact that these measures can't really work 100% largely unignored these days.
Yeah, I think that's a fair point. Do you think AI at any point, even artificial general intelligence, will ever have the ability to be truly creative, or will it just constantly be forever remixing what humans have already done?
Oh, that's one of those philosophical questions again. Can it be truly creative? Are humans truly creative? I don't really think so. We are influenced by our environment. We're influenced by things that we've seen over the years, things that we might have copied from others because we like their style, we like what they've done. We're like, oh, this is really good, but I want to change it slightly, and then I make it my own, right? And in a way, generative AI does the same thing. It really doesn't like completely copycat something, but it learns from all of its experiences and recombobulates that, right? I have my own take on this whole, this is my intellectual property, my artwork, and this AI copied it. I don't think so, because honestly, if I as a human being walk into a gallery and I look at your paintings, I really like your style, and I go home and I try to recreate that style, did I steal your intellectual property? No, I was inspired by it. It's a difficult subject, to be honest. I do think, though, that AI will have a dramatic impact on creative professionals, especially the ones that are working in, let's say, not the fine art spectrum, but more the commercial space. I think a lot of them will be replaced by it.
Yeah, I think that's a fair assessment. This is kind of along the same vein, and this is purely an opinion. But do you ever think that like this AI-generated art, music, or writing will ever have or be as like quote unquote meaningful as human creative works, and why?
I think 90% of the human creative works are not meaningful. They're just commercial. So I honestly don't think that true artists will be influenced by AI because they're expressing themselves in their work. It's not a copy of something. It's not for commercial content. So they will still get the same enjoyment or appreciation from others for what they're doing as they have done for centuries. For commercial art or illustration, illustrative art, etc., yeah, that will mostly be replaced by AI, I believe, because it's more mechanical in nature. I'm not saying that these people don't express themselves in it. It's just more commercial.
Yeah, no, I think that's very fair. As someone who has to make a lot of graphics for marketing, I do not put my heart into those. Like,
right, and you would have no. Yeah, why would you not use AI for it? And you know, maybe there's going to be a new AI artist, because honestly, having AI generate these images requires a human operator. Somebody is formulating these prompts. Somebody is sitting there and twiddling with this thing until the result is something that they like. So who's the artist? The AI or the person controlling it?